Alright, in this video we're going to be talking about the integer type. And what I'm going to do compared to what other people on YouTube are doing is that I'm going to teach you how to use these programming concepts in depth. I'm going to just show you more than just making a variable in an integer type. So what I noticed that a lot of people will just show you how to make this, right? See this right here? So this is the variable number, and then I assigned it 100, and then number 2, and I assigned it 200. And then the negative integer types. So number 3, I assigned it negative 100, right? So what a lot of people will do is they'll teach you just this concept, which is good. It's not bad. And then they'll just move on to a different topic, which could either be floats, strings, or booleans, right? Those are other important data types that you're gonna see in the Python programming language. But what they don't teach you is that it's actually there's more to these data types, right? So as you can see here, this is the integer type. So this is the basic, what a lot of people show you. As you can see here, the positive, the negative, and then 0. But look at here, as you can see, you can also convert other data types into integers, right? As you can see here, this is converting an integer into an integer. This was converting a string, which would be text, into an integer. So this will turn into this. And then here, this is a float type, right? Because you see the decimal, and then you see the true. You're turning a true, which is a Boolean type, and false, another Boolean type, into numbers. It'll be 1. So 1 can be represented as true, and then 0 can be represented as false. And then it's turning these here, this binary representation, into an integer type, which would be, I guess, 5. And then A, which is a hexadecimal representation, will be turned into an integer type, which would be 10. So as you can see down here, these are arithmetic operations. Obviously, math is very important in programming. As you can see, these top variables here, A is assigned 10, B is assigned 3, and then obviously you got print A plus B equals, obviously 13, and then A minus B is negative 7, and then print times B is 30, and then A divided by B is 3.3333, which is a float. And then you got the for division, which is 3, print remainder 1, and then exponentiation, excuse my pronunciation there, but it's 1,000, right? And then you got this unary and increment operations. Python doesn't have plus plus or negative negative, but you can reassign, right? So this is important here. I personally use these increment operations from time to time. So as you can see here, this top variable x is assigned 5, right? So x plus equals 1. So what happens is that over here on the right, this, since it's by 1, will turn this one into 6. So instead of it's kind of like addition, right? But this symbol here is used to add into the variable over here. And if it's in the bottom of it, as you can see here, how they're stacked, this one, so the variable x equals 5 is no longer 5 anymore. This one's being updated down here, as you can see. So this turns it into 6. So it's obvious, right? 5 plus equals, add 1 will make it 6. And then the bottom one is, this would be 6 because it's updated, right? Because of up here, negative equals 1. So you're obviously going to take 1 away. It'll turn it back to 5. And then x over here equals negative x, so it'll negate it, so it's going to make it into a negative number. As you can see there, you can see the little negative sign right there. And then you got the comparison types, which will compare it, right? And it'll either give you a true or false answer. So as you can see here, right, x and y, and you can assign variables in this manner as well along the same line. So x is 10, and then y is 5. Print, so x is greater than y. That is true, obviously. 10 is bigger than 5. So 10 is less than 5, which is not true, false. Print x So this is the equal operator, right? So two of them. So it's going to compare if x is equal to y, and that's false because it should be 10 10 up here, but it's not true. It's 10 5. So this is false. So is 10 not? This is the not. This is the not, like not representation, right? So 10 is not y. So this is true. 10 is in 5. So if it was 10 over here as well, it'll print it out as, oh no, excuse me. If if 10 if it was 10 10, this would be false because 10 is 10. But 10 is not 5, so that's why you see that it's true. You see that? And then x over here, so it's either equal to or greater than y, which is true. So it's doing two things. So it's checking if it's greater and or equal to, which is true. It's not, no, excuse me. It is greater and it isn't equal to. And then the bottom here, it's the same thing. Is it less than or equal to y? No, 10 is not less than 5 and it is not equal to 5. And then you have other built-in functions that works with integers, as you can see here. These are examples. PO2, dev mod, round 5808, sum 1 2 3, max 1 4 3. And then you got bind, as you can see here. And then we're going to go a little bit more down here. Integer, formatting, and display. Convert and print in different bases. So n variable is assigned 42. And then print, bin, and then it'll, because it says 42, this will be represented in, in binary. That's what that is. I'm assuming that's what bin means. And then octal. So you can see it's being represented down here. And then obviously this is hexadecimal, right? So this is the hexadecimal representation of the integer number 42. So these are many ways, again, that you could use integer types. And then down here you got format numbers nicely. And then obviously we have 1 million here. Num 1 million. F num. Ooh, looks like this this here will add the commas perfectly to our integer here. And then here it's going to put underscore instead. It does the same thing except it's underscores. And then down here, zero padding, like you see there. And then working with ranges, for loops. Integers are essentially for loops and indexing. So for I in range of 5, print I. So I'm assuming this is either going to count up and then stop, right? Because loops, what they do is that they work as long as whatever's inside of them is true. Once it's false, it stops working. So I'm assuming this will count up. So let's try that out. Let's see what happens. Or Control V. Shortcuts are super nice. Control S saves it. Let's run this bad boy. Hold on. Okay, Python 3. Yeah, I knew it. You see how it counted up? But a lot of programming languages, 0 is actually the main starting point, or 1. So that's why you don't see 5. So it'd be like 0, 1. So it'd be like 1, 2, 3, 4, 5, right? But instead you start out at 0, which is kind of weird. I don't know why programming languages work like that, but they just work like that. That's why you see it end at 4 instead of 5. Instead of it counting 1, 2, 3, 4, and then 5 here, it counts from 0. For some reason they do that. You're gonna have to Google that yourself and learn about that. I don't know. Programming languages can be weird sometimes. And then you got the range variations, right? So let me expand this a little bit bigger. Let me see. Range, right? And then it'll count again as well. And then range. Let's do this. Copy it. Let me copy the. Oh. Control V, and then Control S. Let me see if I can make this a little nicer. Control S. Let's see. Let's run this bad boy again. Oh, you know what? I messed up. I need to put that inside a print statement, I'm assuming. So print. And then I'll do this range. Then we're going to put a 5 in it. And we'll do that one right now, just for now. Ooh, look at that. 0 to 5, huh? 1, 2, 3, 4, 5. So, okay, yeah, so you see how that works. So now an integer division tricks down here. And then it's assigning A, B to 7 and 3. And then Q, R, div, mod, A and B. Quotient and remainder. So I was telling you can use these functions as well, right? Here's another function. Obviously, you got the print function. So 2 and 1. So it's dividing. Looks like 7 and 3. And it's the answers are 2 and 1. And then the bottom, we see simultaneous assignment, hours, minutes, and then again it's using dev mod 130 and then 60, and then print hours, minutes, 2 hours and 10 minutes. And then you got this one here, bitwise operators, advanced but powerful. Bitwise operations act on the binary representation of integers. Ooh, nice. So A equals 5, B equals 3. Dang, look at that, look at that. That's interesting. Looks like it's converting the binary versions. Used in cryptography, file permissions, performance optimization, network mask, and operations. Working with math module. Import math, variable x is assigned 25. Print, square root. Let's copy all these. Let's see what they say. Control S to save the bad boys. What the heck? Oh, that's right. I didn't import the math. Whoops. Whoops. Let's see if it'll fix it. What? Oh, that's right. I didn't even assign. I forgot that. X equals 25. And then my semicolon, because I got that habit from Java. Let's see, there we go. Looks like we ran these bad boys. All I see these functions here are what stands out, right? So so these functions of math, you can use factorial, SIL, floor, GCD. So more advanced mathematic concepts were. Which I'll be with you, I don't use, but it would be definitely helpful for somebody who, I don't know, programs something that's extremely math heavy, or maybe like some sort of tool using instructions. I could see how something like this would be very helpful for a person like that. But now we're here, look at this, the large integers, right? That could be 99 gazillion, right? And then it's multiply them. Dang, that's crazy. Print Y and then print type Y. So this will tell you the type, right? Which will say integer. This is still an integer, even though it's long. And then you times it by enough. That's crazy. That's gonna be a big number. So then you got random integers. So this is cool. I like this. I like so if you ever want to make a game where you have to guess a number from 1 to 10, this random function here, random dot random integer, and then you put the number range. So I want to pick a number from 1 through 10, right? It'll randomly scramble it. And people use it to make games, lottery games. Maybe you can be using casino games, you know what I mean? Anything that needs like a random number printed out. These functions are a great way to do it. And then checking integer type, like I was telling you earlier. I guess this one's different here, is instance. And then here, the type will tell you the type of whatever the variable x is, which is 10. I just looked up here. So it'll be an integer. So obviously, this is an integer type, and it does equal integer, so that'll be true. So instance is instance. So 10 is an integer, and yes, this is an integer, so that will be true. Integer conversion examples. As you can see here, now you're converting different data types into integers. Again, it could be a string like you see up here with the green, and then the booleans, right? So it could be 1, it could be 0, and then you're converting a float type. So this will be 3,999. There ain't gonna be no point. And then you see the integer and conditional logic. So obviously it's doing some sort of a control flow statement with integers. So x equals 5. So if x, which is 5, print truthy, all non-zeros integers are true, which it'll print, because as long as it ain't a 0, it can be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a true. So again, all non-zero integers are true. It's gonna print that statement out, truthy. If not 0, 0 is falsy. This will print on the bottom here, as you can see, if not 0, if this statement was false, but it was true, so it didn't fall off to this one. So then we see using integers in lists, tuples, and dictionaries. So this topic will be its own thing in its own video as well. Using integers, lists, tuples, and dictionaries. As you can see here, these are some examples, right? So normally you can assign a variable just one number. On these list types, you can assign them 1, 2, 3, 4. You can give them 4 variables. And then you call on them by using like I forgot the name of that symbol. Let me see. Coding symbols. So it would be this one, these square brackets. And then you would put a 0 here. So it'd be something like this. So let me get that again. Where's it at? Okay, so here. So yeah, this is a good example, except this is actually going to print all of them out. 1, 2, 3, 4, 5. This is 1, 2, 3, 4. But normally here would have a square bracket. Here you would put a square bracket, and then you would put 0. 0 would call the very first one, so it'd be this one. And then you could put, square brackets, and you could put a 1 in it. It'll call 2. Remember how I was telling you that weirdly the countdown on some of these programming languages, if you put 1 through 5, it'll be 0 through 4. So it's the same thing with the concept of this stuff. So that's how you call on it. So it would be like this. This is how you would call. So let's do it again real quick. Nums equals, again, square bracket, and then we do 1, 2, 3, right? And then to call on it, print, you would do nums, and then square bracket, and then you do 1 like that. Oh, 0, and then you would call this one. And you can do this, and then you call this one, and then you do this, and then you call that one. So we're gonna go deep into that later, but And then you got integer encoding and bytes, as you can see here. More of the fancy representation of it. This is actually how computers communicate, this sort of stuff here. But they convert it to human-friendly text. So this is what we use, right? And then integer rounding and precision, x. We're going to assign 5 divided by 2. Print integer x truncates to 2. And then print round x3 rounds to 2, etc., etc. And then edge, case, and gotchas. Integer. So this, I don't know, what is it? Value error must be whole string. Yeah, that's what I was about to say. That's a float type. Integer float. And then 3.14. Ooh, again, it's just converting it, I guess. Or I don't know. This is interesting. Because it's, you see how it's integer from the outside, but then in the inside here, on the brackets, it's a float 3.14, right? So I'm assuming it's gonna convert both this and this string into an integer type 3, and then obviously you're viewing the binary types right here, this one, and then octal, literal, and then the hex literal. Alright guys, what I'm going to do is that I'm going to try to save this into a file, and then I'll make it available so you guys could use it. And maybe next time as well actually start programming with this, because you'll actually, the best way to program is if you actually type right next to it. And I'm going to do that on my next video, where I'll actually type what I'm seeing, because that's a great way to remember. Like, you can't learn how to play the guitar by looking at chord diagrams or scales right on a book. Yes, you can understand that it's in the key of something. Yes, you understand that those are the correct notes in that key, but if you don't do it, you know, you're never gonna play the guitar. You know, you're never gonna learn how to be good at it. You have to practice it. And I'm definitely going to do that next video. I just wanted to give you guys an overview of what we're doing. And the next one, we're going to go deep into strings. And then after that, we're going to go deep into the float type and then the Boolean type. Alright guys, well, thanks for watching my video. Please hit the subscribe button, like, share, and I hope you enjoyed my learning style. If you have any what's that? Any like critiques or anything like that, let me know. Like, I'm open to anything, how I can improve the videos, if the mics are bad, if you want to hear a little bit of music in the background, etc., etc., let me know. Alright guys, peace.